Hello everyone, this is Atul Mishra, lecturer in Mechanical Department of Praveen Patil College of Diploma Engineering and Technology. Okay, we are studying automobile engineering. In this subject we have completed or you can say we have studied about the introduction of automobile, the classification of automobile in different bases. Then we have seen transmission system in automobile, what are the components involved in transmission system, like you can say clutches, gearbox, propeller shaft, differential. We have studied functions of all the things. Then we have seen different types of axles, full floating axle, semi floating axle we have seen. Then we have seen half axle, full axle, steady axle, moving axle. Then we have seen different types of tire, suspension system. Okay, we have seen braking system, steering system of automobile. Now after everything, the electrical system is very important in case of automobile. Okay, there are some electrical components which are used in automobile, but nowadays you can say the whole vehicle is running on the electricity, or you can say on battery. So electrical system is also a very important part of the automobile system. Okay, because we are totally moving from IC engine to the electrical system. Okay, nowadays electrical cars are also there, hybrid cars are there. Okay, so study about electrical system is very important as an automobile engineer. So this is the first unit, sorry, fifth unit, unit 5, automobile electrical and electronic system. So what we are going to see in this video, introduction to electrical and electronic system. Okay, so the first and very important, very basic thing is electrical voltage. Okay, what is electrical voltage? So electrical voltage is defined as the electrical potential difference between 2 points of an electric field. Okay, electrical voltage is the electrical potential difference between 2 points of an electric field. Means there will be some potential difference into when we consider 2 points, or you can say, for example, you consider there is 2 beakers. In that particular 2 beakers we have filled, in first beaker we have filled 200 ml, and in another one beaker we have filled only 10 ml. When we join that 2 beakers, so the electrical flow, or you can say water, is going to be flow from that 200 to that 10. Okay, so this is the potential difference. I'm giving you an example. So through this, when we connect these 2 beakers, the water is going to be start flow. So at the same phenomena is going to apply in the case of electricity also. When we connect to point, and that point having different voltage, or you can say different potential difference, then electricity is going to be flow. Using water pipe analysis. Okay, there is an example. Using water pipe analog, we can visualize the voltage as height difference. Yeah, that makes the water flow down. Right? That same example of beaker you can consider here. Okay, V is equals to omega minus omega. This is the potential difference. V is the voltage between 2 and 1 in volts. Okay, this is the unit of voltage, is capital P, called as volts. Okay, is the electric potential at point 2, another one is electric potential point 1 in volt. These things going to be in volts only. In the electrical circuit, the electrical voltage V in volts is equal to the energy consumption E in a joules. Okay, in electrical circuit you can say that electrical voltage V, okay, is equal to the energy consumption. Means whichever, or you can say whatever amount of voltage we are going to supply, or whatever amount of energy is going to be consumed, okay, are going to be equal. Means V is equals to J, okay, in an electrical circuit. V volt is going to be in volts and energy is going to be in joule. Okay, divided by the electrical charge Q in coulombs. Okay, V is the voltage measured in volts, E is the energy measured in joule, J, that is Q, is electrical charge measured in coulombs, that is C. So this is about the electrical voltage. Now we are going to discuss about the electrical current, that is electric current. Electric current is the flow rate of electric charge in an electric field, usually in electrical circuit. Okay, using a water pipe analog, we can visualize the electrical current as a water current that flow in the pipe. Okay, how you can visualize it? That is or you can say electric is flowing. So what they are saying, electric current is the flow rate of electric charge in an electric field, usually in an electric circuit. Okay, means there is an electric circuit in which there is an electric field in which there is an electric charge. Okay, if you take an example, so there will be a pipe, water pipe, in which there will be a water. Okay, there will be a water which is going to flow inside the tube. Okay, means the water is considered water as an electric charge. Okay, and inside the pipe there will be a lot of water, so that will be a field of electric charge. Okay, or you can say electric field. And electric circuit considered as a that water tube. Okay, when the water start flowing from that tube, means the electric current, means the electric charge is going to flow from that electric circuit. Okay, by the comparison of that you can visualize the flow of electric current. Okay, the electrical current is measured in ampere, AMP. So the unit of electric current is amperes. Next, now electrical resistance. Okay, resistance in an electrical quantity that measured how the device or material reduce the electric current flow through it. Okay, means the device, okay, the amount of electric current it can resist to flow, it can called as the electric resistance. Means some you can take an example like if water is flowing from the pipe and you want to resist. Okay, how you can resist? You can reduce the diameter of the pipe, or you can increase the diameter of pipe. Okay, are you getting it? When you reduce the diameter of pipe, so it going to resist the flow of water. Means it is resisting the flow of water. Okay, the same function is going to be performed in this electric circuit. There will be a device which is going to be resist the flow of electric current. Means it is going to be less conductive materials. Okay, it can be semiconductor materials. Okay, resistance, for resisting the flow of current, we have to build a barrier in between the electric circuit, which is going to resist the flow of electricity. Okay, the amount of electricity it is going to resist, that is called as the electrical resistance. Okay, that resistance is measured in the unit of ohms. Okay, the unit of resistance is ohm. There is an example. If we make an analog of a water flow in the pipe, the resistance is bigger when the pipe is thinner, so the water flow is decreased. Okay, as I have taken an example of a pipe. Through that pipe water is flowing. When we reduce the diameter of pipe, so the amount of water flowing through that tube is going to be decreased. So there is the same phenomena in the electric circuit. Okay, when we connect a resistor in that particular circuit, so the amount of current flowing through that circuit is going to be decreased. Means we have resist the flow of electricity by using resistors. Okay, so the amount of electric current we have resist to flow is called as the resistance, and it is measured in unit of ohms. Means the unit of resistance is ohms. So R is the resistance in ohms. So resistance is denoted by R and the unit is ohms. Okay. Now electric power. Electric power is the rate of energy consumption in an electrical circuit. The electrical power is measured in the unit of watt. Okay. This is very simple, you can understand. These are the some components which are used in an electric circuit usually. So we have resistors. This is the resistor. Let's see. This is a resistor. How it looks like. This is capacitor. This is inductor. This is diode. This is LED bulb. This is transistor. This is IC. This is a relay. This is battery. Okay, by seeing this component you can identify the name of that particular component in a circuit. So these are commonly used, so you must know about this. Now what is diode? So diode is a two terminal electric component with asymmetric conductance. It has a low resistance to current in one direction and have high resistance in the other. This most commonly function of a diode is to allow an electric current to pass in one direction while blocking the current in opposite direction. Means, if I say in a simple language, so the diode is allowed to flow the flow of a current in only one direction. And how it is going to perform that? So it having two terminals, in one particular direction it is giving a very high resistance. Means through that particular terminal the electricity cannot flow, and in another terminal it is giving the very less resistance. Means through that particular direction the current can flow easily. So this is how it is performing the this is allowing the flow of a current to pass from only one direction. Okay, means the reverse direction current cannot flow. So this is the function of diode. Okay, thank you.